So this is our next question from Cat 23 slot 2. You can try this question and you can resume the video for the solution, guys. Okay, so the question reads, a triangle is drawn with its vertices on the circle C such that one of its sides is a diameter of C and the other two sides have the lengths in the ratio A is to B. If the radius of the circle is R, then the area of the triangle is. Okay, pretty simple question. In fact, this was one of the simplest questions of the lot. Let's see how we deal with this. So this is our circle and three vertices of the triangle lie on the circle with one of the sides being the diameter. So if I call this side as, let's say, PQ, PQ is the diameter of the circle, and then we have the other two sides as QR and PR. Okay, so PQR is the required triangle. Now, as per the question, PQ is the diameter of the circle, right? A diameter always subtends a right angle at any point on the circle. That tells you angle PRQ should be equal to 90 degrees. And the other two sides, apart from the diameter of this circle, the longest side of the triangle, basically the hypotenuse, the other two sides are in the ratio A is to B. Okay, so let's call PR and RQ in the ratio A is to B. Let's call them as A into X and B into X. Now the next tip to understand is PQ is the hypotenuse for the right angle triangle. It is also the diameter of the circle as per the question, right? So if the radius of the circle is R, PQ is twice of R. Let's use our Pythagoras theorem here. Using our Pythagoras theorem, AX square plus BX square should be 2R the whole square. That gives me A square X square plus B square X square is 4R square. If I take X square common from both the terms, I'll be left with A square plus B square, and that is worth 4R square, right? Now let's take A square plus B square below on the right hand side. We will get the value of X square as 4R square divided by A square plus B square. That is the first step of our solution. Now they're asking us the area of the triangle, guys. For any right angle triangle, the area is half into product of the perpendicular sides. So the area required is half into AX into BX, which eventually becomes half into AB into X square. But X square's value we have already found. Let's substitute here. So in this case, we will get half into AB into, in place of X square, we are putting this 4R square upon A square plus B square. Cancel out 2 and 2. The final area is 2R square AB divided by A square plus B square. This is very clearly your option D. Now this is one way of solving the given question. I'll tell you a quick shortcut for this one now. Okay guys, so now let's look at a quick shortcut to deal with this question. We have the circle and the triangle has one side as the diameter. So it's a right angle triangle. Now for right angle triangle, we know the Pythagoras theorem, and we also know that the sides that satisfy the numbers that satisfy the Pythagoras theorem, they are called as Pythagorean triplets. So we can take any one Pythagorean triplet and solve the question very quickly. Let's take the 6, 8, 10 Pythagorean triplet to solve this question. If you take the 6, 8, 10 Pythagorean triplet, the sides in the ratio A is to B, those sides are 6 and 8 in value, and the hypotenuse is the diameter of the circle. So radius will be half of 10, and half of 10 is equal to 5. Now the area of this right angle triangle should be half into product of perpendicular sides, half into 16 to 8, that is 24. And now we plug in the value of A as 6, B as 8 and R as 5 in the options and check which of these options yields the value 24 as the area. Very clearly it is your D option. In the D option, the area comes out to be 2ABR square divided by A square plus B square, substituting 2 as it is. In place of A, I substitute 6. In place of B, I substitute 8. R is basically 5. So R square is 5 square divided by A square plus B square is 6 square plus 8 square. That becomes 2 into 6 into 8 into 25 divided by 100. 25 4s are 4 2s are 6 2s are 12, 12 2s are 24. and thereby the answer is option D. So this is the approach which I use in the actual exam also, and that gave me the answer very, very quickly.